Welcome to this PLC tutorial guys. In this tutorial we will learn about NOT, NOR and NAND gate in PLC. So let's begin. First let's start with the NOT gate. A NOT gate flips, or you can say invert, the input. It will output 1 if the input is 0 and it will output 0 if the input is 1. Now let's see how we can make the circuit of NOT gate in PLC software. So first I'm going to create the tag. So I'm clicking here show all tags, and first input is going to be input A, and for the rest of the gates I'm creating input B and an output. The identifier for input is I and output is Q. So here the output should be Q. So I am changing the identifier from I to Q and check this box. As you can see, we are done with the tags. So I'm going back to the program, and here I am going to drag the normally closed contact here. This will allow to invert, or you can say flip, the input, and also I will be using an output. So I am assigning input A to this normally closed contact, and I am assigning a tag of output to this output. Now we are done with the circuit. So first we have to click on start simulation. In my case it is already started, so I'm clicking on download button, click on load, and now turn on the monitoring mode. And here is the project view. From here we can toggle the switches. So as you can see, when the input is 1 the output is 0, and when input is 0 the output is 1. And that is basically the logic of the NOT gate. When the input is 0 output is 1, and when input is 1 output will be 0. Now let's move on to the NOR gate. A NOR gate outputs 1 only when both inputs are 0. For the rest of the combinations, the output will always remain 0. Now let's create the circuit of the NOR gate in TIA Portal software. First I'm going offline and I'm going to delete these buttons. Okay, so first I will be dragging the normally closed contact here and again a normally closed contact here in series. And finally I will be using an output here. So we will be assigning the addresses to these contacts. So this will be output, this is input B, and this one is input A. Okay, and now I will be downloading this program. So click on download, because my simulation is already working in the background. Click on load and simply turn on the monitoring mode in order to see the power supply in the green line. And now let's toggle these buttons in order to verify the logic of the NOR gate. We know that the NOR gate output 1 when both inputs are 0. So right now input A is high, input B is high, and output is still low. And the output box is unchecked as well. When we make these inputs low, the output box is automatically gets checked and the output is activated as well. And it says that the output is 1 when both inputs are 0. And now let's move on to the NAND gate. The logic of the NAND gate is such that it gives 0 only when all inputs are 1. For the rest of the combination, it will output 1. Now let's create the NAND gate circuit in the TIA Portal software. So first I will go offline and then I'm going to delete these buttons. In order to create the NAND gate, I will be using two normally closed contact switches in parallel. So here is the first one. For second one, I'm going to create this path and I will be using a normally closed contact here, and I will close this path in a parallel way. And simply I will drag this output here. And now I'm going to assign the addresses to these contact switches. This is going to be output, and this is input A, and this is going to be input B. This tag we have created in the earlier part of the video. Now I'm going to download this into the device because the simulation is already working in the background. I'm going to turn on the monitoring mode, and we know that the NAND gate outputs 0 only when both inputs are 1, and here is the case. Both inputs are 1, both are activated, and the output is low. As soon as I deactivate any of the input, the output will get high. or if I deactivate both of the inputs, the output will get high as well. And you can also verify the logic of the NAND gate from the truth table as well. When both of the inputs are high, the output is going to be low. And this is the case right now. So that's all for this video guys. If you find this video helpful, then please hit the like button and subscribe to my channel. Thanks for watching.